Hello guys, today we're gonna go over real quick over the program we took, how to print a string, do it also in high level. We're gonna do it using the Irvine library. Then we're gonna do it as a low level using Mason, and in that we're gonna introduce today the let's say the those interrupt or the controls, the system calls. How can we do that without any function, without a library? So let's start here. Let's open TextPad. Okay. Close, and we have a new one. So what we need to start with is what? Include. I just want to print a string. Irvine 32.inc, and now I have my .data section here. This is where I'm going to declare my string, and here I have my .code section, and I have my main process. This is how a assembly program looks like, and here we have exit, main, end process, and main. So let's see, I need to print a string. How do we print a string? We use the call write string procedure. So they call it. My string is message. I want to declare it as define it as byte. Define byte, or you can say byte, and I'm gonna have it as, and this is the data type. In assembly we can use either double quote or single quotes, and let's type my name to the output, and here I didn't put any zeros on my main process. And this is, guys, really important now. Now we need to take the offset. The offset meaning the address of the string. The offset of the string, the address of the first element, where the character G is in memory. And I need to move it to EDX. So I'll say move EDX, and I'll move to it offset of MSG. So now we're moving to here. We've got the address of what? Of the string. All we need to do now is what? Call write string. Call write string. The write string is one word, and call, and this is a procedure. Remember, those are directives. This is a library. So let's do tools. Okay, I didn't save it. My bad. Save as, and let's go save it with the Mason's files. Examples. Okay, chapter 3. Okay. What did I do? I need to go rename it. I left it as txt, and that we have to save it as what? .asm. What was the name of it? That's C. Document. Rename. What is it? Rename, and let's say this is our third, yeah. video programs. That was, the P was for that video program. .as. Now that's good. We go back here. I didn't change it. Let's try to see what happens. Same thing, so it didn't change it. Why? Alfred didn't delete it. Okay. Why do I still have that? I renamed it. Let's see how to solve this problem. Let's go back again to it, and I don't want it .txt. How can we change though? Did that change it? Nope. Let's go try it anyway. Let's see what happens. See, it's here. It can't be here. Let's Control A, Control copy, file new, Control V, close you, file, save as, and we're gonna save it as, let's save it as third .asm. Okay, so now it's better. See, we don't have this t.txt. Build, worked, no errors, good. Close this and do again. Run. Change my name, but did you see? We didn't put what? There's two ways to do this, and I'm gonna put here. We can do it using 10, 13, and 0. We don't need the 0, but and this we can use instead of those numbers. The 10 in decimal is what in hexadecimal. It's A8. We can use 0A8, or we can use 13 is 0D8. And why did I put zeros? If I have a hexadecimal number and it's a letter, I put a 0 before it. So from 1 to 9 we don't put anything before them. If from A to F we put a 0. How did I know it's a hexadecimal? From the H. By default assembly is decimal. If I put a B, it's binary. If I put a O, it's octal, and it goes that way. So now this gives me a new line. Caret return, and what? Return it back to here, and new line. Go to the line under it. We also can use code. Well, it's clear. Here's one line. So let's see how this works. Build. What was it? Clear what? Let's see, that's good. I want to go to the Mason, the Irvine library, so we can see the functions, so you can know the functions, you can know where to get them from. Here's the Irvine help library. We go to it. Here's the close, clear screen, clear F. Okay, so if we change this to, why did I put S? Okay, save, tools, undefined simple, call clear F. And why is it undefined? Here they should put you the way how to use it. Calls argument non-return, call clear screen. Okay, this one hold. What's the carried return to standard output? It's not case sensitive, so okay. Oh my bad. What's wrong with me today? Tools, build. Everything went good. We rebuild it again. We run it now, and here's give me two spaces, two new lines. Let's say, like \n, or end line in C++ or C. Now we said we wanna. This is Windows. Now we're gonna go to Ubuntu, and we wanna run a program similar to that one, but here we can't use the Irvine library. So first we're going to do model dot is what? Directive. Usually when I find those are directives. Remember .data.code, and we put it as small, and we have different models. This is the memory model, and usually when we have simple programs we prefer to put it as small. And there's there's flat, there's large, I think there's 9 of them. We'll go over them. And now I need to define a stack, put whatever number you want, 100, and then we have our .data .code, and we have begin. Let's say we don't have main process, and I forgot if it goes with this or no. Now we need to do one thing. We need to move the address of the data segment, where the data is going to be, to DS. And how do we do that? Can I say move DS address of the data? We can't do that. We have to use, remember the rules for no immediate to segment registers, and DS is a segment register. So I need to move it to another register first, and then move it from that register to DS. This works. So this got me the address of what? My data section, and it's gonna have my message, and I'll say define byte, and I'll have gate, Irvine, and we'll have 10, or let's put it 0AH. I'm gonna keep flipping between them so you can know them really good. DH, we can do those, and now this is the important part. This is the most important part. Well, my mouse stopped working. Ooh. And How am I going to do this? Using what? System calls. And what do I mean by system calls? Remember, calling the DOS. Let me show you DOS interrupts. The MS-DOS API is an API which organizes, okay, integer 21. Here they are. If I do move 01 to A8, which is 1, I can read a character. It's like CN character. Think of it that way. Or if I do move 2 to A8, that's like write a character, like saying cout character. And for a string, it's 9. What is 9? Write string to standard output. I need to load what? 9 to A8, and then do the printing. So first thing I need to do is what? Move EDX. I need what? The address, offset of message to EDX so I can print it. Now I say move, we said A8, which is 1 byte. I move 09 hexadecimal to know what it's a cout. Print this string. It's like saying call write string. But I need to do one more thing. Interrupt 21.8 DOS. This is calling the DOS now. It's the kernel that's gonna go do the std out is a system call. So we call this is the number of the system call, and this is the interrupt. This is calling the kernel, calling the DOS. And we can also, we need to do the exit. Remember we had the exit here, and the exit, that's also defined in Kip's library in the Irvine. So we need to implement it, and we'll say move A8, and it's 4CH. 4CH, that's the number for the exit. And each time I do one of the system call, I'll do interrupt 21.8, call the DOS, call DOS. So let's save this as I have too many assemblers. Where did it go? I tried to do the Irvine here, but it didn't work, so it's not working until now, but I'll try to do it. So this is the first, and let's say low level. Low level, LL. Save. And now this is the magic. I need to, how I'm gonna run it on Unix, Linux, what do you think? I'm gonna need, wow, DOS box. You can download this. It's easy to download. It's emulator, emulates the kernel, DOS kernel, so I can run it on Unix. Don't think this is Windows. I'm running on Ubuntu. This is a virtual machine. Here's the DOS box. But here's what we need to do first. I need to mount it. Mount C. Create a C library. In Unix, Linux, we don't have a C, but that's why I need to mount C to what? To my home library, where my assembler is. And if you saw, we went to 886 when I saved it. It's home. Here's my assembler. But this case, it's my. You need to include the full path of the assembler. So it's gonna what? It's gonna take this directory and mount it as a C. So we can now run Mason. So now that's good. It gave me what? Drive C is mounted. We need to do one more thing, is go to that drive C. How to change to C. Let me show you. So now we have this. If you type directory dir, it will show you the files in the directory. The problem with this is you can't play with the mouse and the can't see the ones before that. So you can do what we can do is redirect it to a file, name it gate.txt. This will direct the output of directory, meaning it will take all those files that came out and put it where in gate.txt, so you can go and check it and see which files you want. But we already know we had the first low level .asm. That's not enough. I need to run the Mason assembler. Mason first low level .asm object, leave them as is. Oh, we have an error. What's the error? Symbol not defined. edx. Should it be dx? Okay, it's 16-bit, so we can do editor. We can open an editor here. File, open, or you can go to the one I had open, but I just wanted to show you this. Okay, didn't like this one. Why did I offset? See, it's 16-bit anyway, so file, save, and file exit. No, okay. No errors, so we're good. Now what we do is, first I did Mason assembler. Now we link which file. Now it has already, when it runs good, it will generate an object file for that Mason file. So I'll have .obj, and you can put semicolon or not here, and all right to there. Good, but I didn't print it, yeah? Oh, sorry. let's see, we might need to call the debugger, and it will get a first ll.org, so I can assign its executable file. And now I'll say first ll execute it, and voila, كيف البدر. But now you see it came with garbage, lots of garbage under it. What do you think? What I think is maybe let's go editor. What I think is the problem, come on, you're gonna face lots of problems, so be careful. It's slow. You can increase the speed of the, so I'm gonna open. We need to put a $sign indicating the end of the string. You see the object file and execute file that are generated. And so we put here a $sign, and I think this should work. And I'm gonna run this for you again next video also, so we'll do massim. 1 minute, let's go full screen, massim, and my .asm file. Everything went good. Now I'll do a linking with my object file, which is the same name, and .obj. And first we can try this thing, and now I'll say first here we go. We have also here what's called a debugger, and it's really nice. We're gonna see it in action with, this is the code, this is our code. Which code is it? What do you think? Look at it. What is this part? Oh, there's no mouse. The ones on the 2, or let's say 3 columns on the left, including the column between them. So the 073F, the 0100, the 7403. Not the instruction. What are those? If you can see, those are memory addresses. Memory addresses. And what's the 073F is a memory address. The 0100 is also a memory address. That's the segment, and one is the physical address. And the 7403 is what? Is the opcode, or what we call, it's the value for the gz command. Jump on 0, that's a jump on 0 command, jump 0, 010F. That's what is the code. The one below it, and the gz takes 2 bytes, you know, because why? It's 7403. The jump command takes what? How many bytes? 3 bytes. E99700 to execute. And then we have the move command takes 3 bytes, which is B80500. Then we have the push, which takes what? Because I'm pushing 2. The accumulator takes 51 byte, and then push again with what? How many? 1, 2, 3, 4. Why 4 bytes? and the previous one was what? 1 byte. Think of it. You see the 21 3C? You see it? But it's in reverse order, and we've talked about that. Later we have -U. What else? To print the debuggers, I think it was help. Okay, help. Okay, you want to play that? What was the help? You will quit it, but I don't know. What was it? Show help. Okay, show us help. Help all. I want it for the debugger. Press any key to continue. This should print us all the available options for the debugger, but I don't know why. That should be help debug. Help debug. Nope. I'll check it for you guys and I'll bring it next time. And hopefully this was good. I know it's a little bit complicated, but it's fun. Try to go over it, watch the video twice, 3 times, and I'll go over it with another example next time also. Thank you guys.